Testing knob and tube wiring with an insulation tester is possible, however, is generally not recommended as a routine procedure due to several potential risks. Firstly, stress to the wiring is a significant concern. Insulation testers apply a high voltage, typically 500 volts direct current or 1000 volts direct current, to the wiring. This high voltage can put considerable stress on the insulation, especially if it is brittle or degraded due to age. Secondly, there is a risk of damage. The testing process itself can cause insulation breakdown, arcing, or short circuits if the wiring is not in good condition. This can potentially lead to a fire or electrical shock, creating a dangerous situation. Thirdly, insulation testers often provide limited information. They essentially give a go or no-go result. They do not precisely indicate the actual insulation resistance, which will provide a more detailed measure of the wire's overall condition. However, there are situations where testing might be considered. If there is a suspicion that the knob and tube wiring is damaged or compromised, testing could be part of a troubleshooting process or a safety inspection to assess the extent of the problem. If the decision is made to test knob and tube wiring, it is essential to follow a careful procedure to minimize risks. 1. Always disconnect the power. Turn off the power at the breaker or fuse panel before beginning any testing. 2. Use a low voltage tester. Select an insulation tester with a voltage rating that is appropriate for the type of insulation present. For example, 500 volts direct current may be suitable for rubber-covered wire. 3. Test each conductor individually. Connect one probe to the conductor being tested and the other probe to ground. 4. Record the readings. Note the insulation resistance readings obtained for each conductor. To interpret the results, consider these guidelines. A passing result is typically indicated by an insulation resistance of at least 1 megaohm, which is 1 million ohms. This suggests that the insulation is in reasonably good condition. A failing result occurs when the insulation resistance is less than 1 megaohm. This indicates that the insulation may be compromised and requires further investigation or repair. As an alternative to insulation testing, a more conservative approach involves a thorough visual inspection of the knob and tube wiring. This inspection should look for several key indicators of potential problems. Look for cracked, frayed, or missing insulation along the wires. Check for loose or broken connections at the knobs and tubes. Examine the wires for any signs of being burnt or blackened, which could indicate overheating. Look for any evidence of arcing, such as scorch marks or carbon deposits. If any of these signs are found, it is crucial to have the wiring inspected by a qualified electrician. They can assess the situation and recommend appropriate action, which may include replacement or repair of the wiring to ensure safety. It is important to prioritize safety when dealing with knob and tube wiring due to its age and potential for degradation. A visual inspection can be a safer initial step, with testing reserved for specific situations where damage is suspected.